Hello everyone, how are you all doing? Hope you are doing good today. So today we'll cover some levels and types of software testing, particularly focusing on performance testing, security testing, and usability testing. All of these fall under non-functional testing, tests that evaluate the software beyond just functionality, focusing on aspects like performance, security, and user experience. So, let's talk about performance testing. So, what is a performance testing? Performance testing evaluates how well a software application performs under various conditions, such as high user loads, stress, or different hardware configuration. Now, what are the purpose of a performance testing? There are several purposes like assess responsiveness, then check speed, then test stability, and identify improvements. So by assess responsiveness means how quickly the system reacts to user action. Like if you press a button, how fast it reacts to your click. Then the second part is check speed. It means can the system handle operations efficiently. Then after that, the testability means how application performs when it is pushed to its limits. Okay. Then the last one is identifying improvements. Means areas where performance can be optimized and improve for user experience. For example, imagine testing a platform like Facebook before its release. A tool such as JMeter is used to simulate thousands of users logging in simultaneously. By replicating real-world scenarios, we check can the system handle thousands of users, and does the system crash or slow down under load? So, what is JMeter? JMeter. It's a common tool that replicates user behavior without requiring any actual users, making it possible to test performance at scale before the product goes live. So, performance testing ensures the system is capable of handling its expected load efficiently and identifies weak points before the deployment of the website or product, whatever you can say. So, the second part is security testing. Now, security testing focuses on identifying vulnerabilities or weaknesses in the application so that it can ensure It can protect data or resources from unauthorized access, attacks, or breaches. Okay, now what are the purposes of it? It ensures data security, which means it protects the sensitive user and business data. Also, it prevents unauthorized access. It blocks various hackers or unintended users from gaining access to the website or servers. Then the third one is validate robustness, which means it checks the strength of the platform against different kind of threats. For example, for a banking application, security testing would confirm that sensitive information such as account details, passwords, or transaction data is secure from the unauthorized access. If a hacker could steal such data, it would indicate a failure of security mechanism. So here the key concepts are vulnerabilities and protection against breaches. Like like finding weaknesses in the system that could be exploited, or system, and the system should safeguard users' data and prevent hacking attempts. So security testing is crucial to ensure the platform's robustness and reliability, and maintaining trust and protecting against data theft. Now for the third part is usability testing. Um, Usability testing. So the definition of usability testing can be it evaluates how user-friendly the application is from the end user's perspective, like how friendly the UI is or the website is for the user. Its purposes are ensure ease of use. Like, is the system intuitive and straightforward for the user? Then check user satisfaction. Like, do users feel the application meets their expectation? They find all the functions they desire on the website. And and the third one is to assess the accessibility, sorry. Like, is the product accessible to all types of users? Like, different users can access it. For example, end users test the software to see if navigation is intuitive, the interface is clear, and the features work as expected. For instance, an e-commerce platform should enable users to browse, add, and items to their cart and check out effortlessly. The QA team may act as end users during this test, simulating real-life use cases to evaluate overall satisfaction. So usability testing ensures the software provides a seamless and enjoyable experience for its users and increasing its adoption and success. Now, let's talk about the testing stage and rules. On testing stage, there is pre-production testing. What is this? It's like performance, security, and usability tests typically occur in system integration testing or SIT under system testing umbrella. These tests are conducted in a controlled environment to validate the software before deployment. So it is like performance, security, usability, all are tested under SIT, System Integration Test. The rules of testing here are uh, performance and security testing and usability testing. The performance and security testing is often handled by a specialized team, not the regular QA testers. And the usability testing can be conducted by the QA teams acting as an end user. Now, what is alpha testing? Alpha testing. Alpha testing is conducted internally by the development team before the software is released to external users. This can be this can include testers, developers, product owners, business analysts, or other stakeholders. So there can be testers, developers, product owners, business analysts, etc. They all make into alpha testing. The focus areas of alpha testing are business goals. Business goals are like ensuring the software meets business objectives and requirements. Then users' expectations. So it verifies the user's needs and expectations uh, can be satisfied by the system. The third one is business workflow. This one evaluates the workflow for profitability and alignment with business strategies. For example, for an e-commerce platform, alpha testing checks if the business goals, such as customer satisfaction and revenue generation, align with the product's performance. It also verifies whether the product is ready to meet customer expectations effectively. So alpha testing is crucial to identify major issues early and ensure the system is ready for beta testing or external release. So it ensures system ready for beta testing. Testing at this level ensures a robust security and user-friendly product that meets both business objective and user experience. So you can understand this how alpha testing works, right? Now let's go to beta testing. So what is a beta testing? Beta testing is a process conducted before the official release of a product software. It involves a select group of external users testing the software in a real-world environment. These testers provide feedback to ensure the software is functional, user-friendly, and meets the expectations of end users. There are some key features in beta testing, like selective group, purpose. So for the selective group, the testing is done by individuals chosen by the business team. This could be loyal customers, acquaintances, or volunteers. Sometimes companies open beta testing to a limited public or specific demographics. For example, YouTube beta tester program allows users to opt in and test new feature of the app before their public release. And the purpose is to identify areas of improvement, gather user feedback, and assess real-world functionality and usability. For example, let's go to a workflow. Okay. Suppose you apply to become a beta tester. Then the company provides a beta version of the software with a certain new or updated feature. So the company provides a beta version to test. Then testers use the product and provide feedback. Use and provide feedback. Like they provide feedback about bugs, usability, or potential enhancements. After that, the developers review. They review their feedback and make changes before the final release. So you can ask if the beta testers are paid or not. So usually beta testers are not compensated. It is voluntary and often done by enthusiasts who want early access to the software. So the business team organizes and oversees beta testing but does not perform technical testing themselves. They collaborate with developers and testers to understand the feedback. And they might attend the meetings or request screen sharing sessions to view how the product behaves in real world usage. So beta testing is the bridge that fulfills the gap between internal testing and final release. It provides the real user perspective and ensures the product aligns with expectations and is ready for launch. So it is between internal release to final release. It is the bridge. Now, let's talk about SDLC. SDLC or Software Development Lifecycle. It usually consists of phase designed to guide the development of a high-quality software product efficiently. Each phase has distinct goals, deliverables, and participants. So they have goals, deliverables, and participants. In SDLC workflow, the first step is the phase one is CRS. So what is a CRS? CRS is a blueprint that outlines client needs, objectives, expectation for the software product. So clients needs, objectives, etc. It includes like what product should be featured, the detailed specifications, requirements, and constraints, and it has estimated costs and delivery schedules. So, who prepares the CRS? It is typically drafted by the business analyst and product owner. With the input from the business teams and clients. And business owners and stakeholders may initiate the discussion, but technical experts help refine the details. There can be multiple walkthroughs conducted to clarify any ambiguities in client requirements. Then the second one is HLD or high level documentation. Its purpose is to provide an overview of system design, overview of system design and functionality without diving into granular details. And it ensures business stakeholders understand the project's progress. So here there are system requirements specifications (SRS). It covers both functional and non-functional scalability is non-functional aspects. And there is also FRD, which is functional requirement documentation that focuses specifically on functional details of the system. So it has SRS and FRD. Then project backlog. So what is a project backlog? It is a prioritized list of tasks and features to be developed, often represented as user stories. So it has user stories. It is usually prepared by the product owner. So why is it important? The product backlog is important because it helps to understand which features are critical and need immediate attention. It also schedule and allocate resources effectively. Then the next one. The next one is BRS, Business Requirement Specification. BRS translates the product backlog into detailed scenarios, acceptance criteria, and functional specifications. It bridges the gap between high-level documents and actionable development tasks. Okay, so it detailed scenarios and acceptance criteria. It may include functional requirement, technical acceptance aspects, and acceptance criteria. The goal of the BRS is to ensure the team has a clear understanding of what needs to be developed and tested. In SDLC, there are two things. First, the granularity is key. Candidates often struggle to provide detailed answers about SDLC phases during interviews. Breaking down concepts into clear and actionable steps demonstrates a deep understanding. And also, there is technical versus non-technical roles. While business people may not run tests, they ensure alignment between the client expectations and development progress. By emphasizing clarity in beta testing and SDLC, you can articulate your understanding of both concepts effectively in any academic or professional context. Then let's move on to the pre-refinement session. The pre-refinement session is to prepare the business requirement specification and ensure it is smart, like specific, measurable, achievable, relevant, and time-bound. And this stage focuses on static testing and verification, enabling early identification of errors. So its main activities are introduction to BRS. Business Analyst introduces the complete user story and explains the requirements to the team. The objective is to ensure everyone understands what needs to be built. Then comes smart validation. It ensures the BRS is S for specific, M for measurable, A for achievable, R for relevant, and T for time bound. So specific is like it clearly defines system expectations, behavior, and features. The measurable has clear criteria for acceptance. The achievable means that it is feasible within budget, timeline, and it is resource constraints. The relevancy is aligned with the project's goal, and the time bound, it ensures that it is delivered within the project schedule. Then the third one is priority and severity. The priority focuses on importance of fixing a problem based on its impact on the customer, and the severity assesses how critical the problem is to the business or application. Then the fourth one is static testing. In static testing, it is used for reviewing design documents, source code, and requirements for issue without executing the application. It includes walkthrough meetings for clarifications and inspections. So as a result, the outcomes are verified user's story, then prioritize issue, prepare ground. So it is used to it verified and inspected user stories, and it prioritized and categorized issues based on their impact. It also prepares ground for further discussion in the refinement session. Now let's go to refinement session. The purpose of the refinement session is to plan the technical execution of the requirements, focusing on effort estimation, resource allocation, and methods to implement the user stories. Here, the key participants are developers, testers, and architects. The key activities of refinement sessions are effort estimation. In effort estimation, it estimates the time and resources required for development and testing. Here, the developers and testers discuss uh, tools, technologies, and different methods to implement the requirements. Then they go to the technical discussion. Technical discussion. In technical discussion, developers review the design documents provided by the architects. They identify technical dependencies, risks, and tools needed for the implementation. Then comes the division of work. Here, the tasks are divided among developers based on their expertise. The testers plan test scenarios and identify test data requirements. Then comes sprint goal drafting. Here, a high-level draft of the goals for the upcoming sprint is created based on discussions. So, in the refinement session, the outcomes The outcomes are refine user stories with effort estimation, then detailed technical understanding, then the initial alignment on sprint objective. So so we can say that the pre-refinement session is the static testing and verification to ensure clarity of requirements. The requirement refinement session is focused on technical planning and effort estimation. The requirement analysis continuation is requirement analysis extends from pre-refinement to sprint planning. So let's discuss now about effort estimation. Okay, let's start by talking about effort estimation. Now, when we think about estimating effort, we're talking about figuring out how much time and resources are needed to complete a task. This is something that happens not just in testing but across the entire project team. Okay? Developers, testers, business analysts all need to have a good sense of time and effort involved. As a tester, you'll often hear the term user story points. Okay, so you will have terms user story points. These are essentially a way to quantify effort. Let me give you an example. One company might decide that one user story point is equal to 4 hours of work. So one user story point equal to 4 hours. And another company might decide one user story is equal to 8 hours of work. The point is, it's not always about a set number of hours. What matters is the relative effort required to complete the task. Now, why do we use user story points instead of just saying it will take 8 hours to complete this? Well, user story points are used to help justify and communicate how much effort is required to complete a task. This isn't just for developers. As a tester, you will be involved into this as well. It's about understanding time needed to run tests and ensure everything is functioning properly. When we talk about effort, we are referring to realistic amount of time. So effort sum equals to the effort is like the realistic amount of time requires to build or test a feature. Think of it like this. It's not about saying I need an hour to test this. It's more about taking into account all different factors and might affect how long the task will eventually take. Environmental setup, unforeseen issues, dependencies. things that all contribute to effort. Now, what are roadblocks and dependencies? Now, let's dive into something that's really important when estimating effort. Roadblocks and dependencies. These two things are key to understanding what might slow us down or stop us from moving forward. Let's start with roadblocks. Roadblocks are obstacles that get in the way of the progress. For example, imagine you are given the task to test the login feature of a website. Pretty simple, right? But what if you don't have the login credentials to access the system? That's a roadblock because it's something that's completely stopping you from testing. You can't do anything further without those credentials. Now let's talk about different dependencies. Dependencies are situations where you rely on someone else to move forward. So in our example, the login credentials you need to test are something you are depending on a developer to provide. If the developer doesn't give you those credentials, you can't proceed with your testing. So you are dependent on the developer to provide you with the test data, like login credential. That's dependency. Dependencies are critical because without clear communication, we could end up in situations where we are waiting for someone else to do their part before we do ours. So, all right, now we understand effort estimation, roadblocks, and dependencies. But how does all of this come together in practice? That's where refinement session comes in. A refinement session is a meeting where the team, developers, testers, product owners come together to discuss the work that needs to be done for a particular sprint. Here, the team refines the user story by breaking them down and assigning user story points based on effort. The idea is to make sure that everyone has a clear understanding of what needs to be done and that all dependencies and roadblocks are identified early on. In a refinement session, you will hear the developers explain how long they think a feature will take to build in terms of story points. And you'll hear the testers explain the amount of time needed to test the feature. This is where you, as a tester, would talk about the test data you will need. Maybe you need access to certain accounts or certain pieces of information. This is when you'll raise your dependencies and say, hey, I need these credentials from the developer to proceed with my testing. At this stage, everyone makes sure they're on the same page about who's doing what, what's required, and how long this will take. It's a collaborative effort to align everyone's understanding. Now, in a meeting, there's a lot of discussion. You may ask questions like, what are we testing? Then you can ask, who will be responsible for each part? Then how much effort will each partake. The minutes of meeting are critical here because they document everything discussed during the refinement session. This is where the dependencies and roadblocks are officially noted down. Now you may ask what happens before refinement. Before refinement, it goes to workshop meeting. Before a formal refinement session, there are usually a lot of informal discussion happening. They are called walkthrough meetings. These are not official, so they are not official. They are just a chance for developers and testers to plan things behind the scenes. Developers might have had their own separate walkthrough meetings to discuss the feature they're building. Testers also might have theirs to figure out what needs to be tested and how. These meetings are usually informal. There are no official minutes taken, and mostly brainstorming and planning. Developers and testers aren't really interacting with each other during this time. Instead, each team is working separately, figuring out their own needs and timelines. They might be deciding on things like what tools to use, what resources are required, and how long will it take. Once they have their plans ready, they will bring everything together in the refinement session, where the final discussions are made. To give you an example, let's go to the login feature. In the login features, let's talk about the dependencies and roadblocks, how they might play out. For dependency, as a tester, you need the login credential from the developers to begin your testing. If the developer doesn't give you the credentials, you can log in the website. That's clear dependency. And for roadblock, imagine the developer is sick or maybe they are working on different priority. If they are not providing you the login credentials, then that's a roadblock. It's something that's stopping you from moving forward. So in the refinement session, the goal is to make sure everyone knows what they need to do, what dependency exists, and what potential roadblocks might slow you down for the progress. You will leave the meeting with a clear understanding of who's doing what is required to move forward, and how much time each part of the task will take. So I hope this gives you a better picture of how effort estimation, dependencies, roadblocks, and refinement session all fit together. Do you have any question about this? You can ask. Now let's discuss about effort estimation and user story. points. So let me ask you something first. Do you think it's possible to just assign some points to a user story based on your own preference? Like if you feel like giving a user story 5 points, you can just go ahead and do it? No, right? It's not simple as that. The point that we assign to user stories aren't arbitrary. There's a point behind it, and you can just assign points based on your own wishes. You need to justify why you think a certain amount of time is required. This has to be rational and logical and detailed explanation. For example, you will need to explain what tools you plan to use, how you're going to conduct the tests, will it be through automation or manual testing. All of this needs to be discussed, reviewed, and approved. It's a team effort. The point of a user story aren't decided without a walkthrough meeting or refinement session where everyone discusses and reviews these estimates. So the need walkthrough meeting. So in a refinement session, both developers and testers come together to discuss the effort required to complete a task. The main idea here is to officially declare you the points and justify the amount of time you're requesting. This is where you discuss all the dependencies, roadblocks, and technical details, and everyone get on the same page. These meetings can be single or multiple, depending on the complexity of user stories. Now let's discuss the daily stand-up meetings. These are usually brief meetings that happen every day. Do you remember what happens in a daily stand-up meeting? The Scrum Master is the one who schedules and leads these meetings. So it is led by the Scrum Master. The purpose is to track the progress of the work that's been done and identify any issues or blockers. So during the meeting, the Scrum Master will ask, what did you work on yesterday? What are you planning to work on today? Are there any impediments or roadblocks preventing problems? So he can ask, what did you work on yesterday? What are you working on today? And are there any roadblocks? This is where testers will report if they are facing any issues, such as not having the necessary test data or if they are encountering difficulties in executing tasks. It's a quick check-in to make sure everything is moving smoothly. So remember when I mentioned that developers and testers have their own separate meetings? They are called the walkthrough meetings, where each group discusses their each part internally. Now, do you think they interact with each other during the meeting? No. The walkthrough meetings are internal to each group. Developers will discuss among themselves and testers will do the same too. These are not cross-team meetings. The goal here is to ensure each team to work through their own part of the project separately. When do developers and testers interact with each other? They'll get a chance to collaborate during the refinement session when they officially declare their points and raise any issues. That's when they will share dependencies or roadblocks, such as tester needing data from a developer to continue their story. This is when the interaction happens. During these meetings, there are also important documents that are prepared and updated. Can you think of what those might be? They are things like test plans and test strategies. So, other document can be test plan, test strategy. The test plan defines the scope of testing, test cases, resources, and tools. The test strategy outlines the testing approach in more detail. So the test plan has test scope, cases, resources, and it has detailed approach. One thing to keep in mind is that test plans are dynamic. They get updated regularly. Every time there's a meeting on new requirements, the test plan might get updated. For instance, if you need new test data, that information gets added to the test plans. It's important to note that these documents aren't static. They evolve as the project progresses. So let's talk about now in scope versus out of scope. In scope item refers to the objects or requirements that are outlined in the project and are testable. These are things we'll focus during testing. On the other hand, out of scope items are things that are not part of the project or are not feasible to test at the moment. For example, let's say there's a button on a website that's supposed to redirect you to another page, but the page is broken. You can fix it in the current sprint, so it would be considered out of scope for the particular sprint. Next, we have the entry and exit criteria. These are critical elements of the testing process. Entry criteria refers to the requirements that need to be met before the testing can begin. For instance, you might need to ensure that the test environment is set up correctly, or you need to test the data ready. On the flip side, the exit criteria are the conditions that must be met for the testing to be considered complete. This could be something like ensuring all test cases have been executed or all defects have been resolved. These are formalized in documents which help ensure that the testing process progresses smoothly and they meet all required conditions. Now you might have noticed that we keep talking about the things like refinement sessions and daily stand-up. These all falls under agile methodology. Refinement session, stand-up. They are in agile methodology. Specifically, they fall under Scrum. In Scrum, the Scrum Master is the person responsible for scheduling and leading these meetings. They act as the task coordinator, ensuring that everything runs on schedule and that there's good communication between all the team members, developers, testers, or stakeholders. Finally, I want to touch on something important about the test plan and test strategy documents. These documents are constantly evolved throughout the project, and after each meeting or sprint, the test lead might update the test plan to reflect new requirements or test data needed. It is a living document that gets updated as the project moves forward. Alright, now we've gone through the refinement session. Let's talk about what happens after that. The first thing we need to keep in mind that test plan gets updated based on changes during the refinement process. So it's about the version of the product we are working with and the features in the build, not just the user stories. It's crucial to remember that. So after refinement, what exactly gets updated in the test plan? Well, the primary updates include dependencies that weren't clear in the refinements, roadblocks, so dependencies, roadblock, test, data. The dependencies that weren't clear before the refinement, the roadblocks that are identified, and the test data adjustments since we have more clarity about what will be need for testing. Once these updates are identified, the next step for the Scrum Master is to email the updated minutes to the meeting of the team. This is important because everyone needs to be on the same page. Now, if a tester and developer ask for 7 points or more during the refinement session, they need to prepare they need to be prepared to justify it to the product owner. Can anyone guess what it is? It is because the product owner is the one accountable to business stakeholders, and the business stakeholders are the one controlling the financial budget. So if we estimate that much time for a story, we need to explain why it's going to take that long. It's not just a free pass. If you are the one asking for a lot of time, you need to come prepared with a clear explanation. For example, you might say something like, this feature is complex, it requires multiple integrations, and I need additional test data to ensure coverage. Other testers will likely support your justifications if they've worked on the similar task in the past. They'll back you up, and it helps everyone to stay aligned and ensure the estimates are real. Now, let's say we are working on three user stories. One is contact us, sorry, contact us. Other one is sign up and log in. We have identified these three stories need further refinement. And now we need to update our test plan based on those changes. This means adding the updated dependencies, noting any roadblocks, and updated test data. At this stage, testers must immediately bring the changes into the test plan. Testers are the ones who ensure that the test plan stays aligned with the latest updates, and they will bring in this change in as needed. Now we move on to sprint plan. Sprint planning is when we discuss what can be delivered during the upcoming sprint, and it helps us decide which user stories we could focus on. The main goal here is to figure out what can be achieved and which user stories should be prioritized first. We've already done the work of estimating the time needed for each story during the refinement session. So now we need to know how long each feature is going to take. We can plan accordingly. For example, if we knew a feature will take 2 weeks and another 4 weeks, we decide what makes sense to work on first. This is where we figure out which feature we should prioritize in the sprint. For example, in the first sprint, we might work on sign up. So sprint one, sign up. In the second sprint two, we could tackle contact us. And in third one, we could focus on login. Each feature builds on the last. We are not building the entire system at once. We are building it step by step. And you might wonder, well, what if we're building something big like an Amazon website? Can we really build it in one go? Well, no. We can't just build everything in at once. It just happens gradually, each step by step over time. The team, designers, architects, developers need to understand that they are working incrementally. They will start with smaller manageable parts. Like in sprint one, they can create account page. And sprint 2, they can add to cart functionality. And sprint 3, they can add checkout process. Each sprint contributes a new piece to the puzzle. And testers, as part of the process, will be responsible for testing the individual parts that are ready. So, after completion of the sprint planning, we now move on to the design documents, which are prepared by the architects. But why does the architect need to collaborate with the developers? Well, if I, as an architect, give you a design to build something, but it's way out of your skill level, it's not going to work. You need to make sure that what I will design can be made by you. The collaboration ensures the design is practical and within the developer's capacity. Now, once the design document is ready, we move on to the development phase. At this stage, the developers begin coding based on the design document. As a tester, it's your job to start thinking about how you will test this code once it's developed. You may start preparing test cases, or write scripts that can ensure the tests are done efficiently. Now that we have covered the basics of refinement, sprint planning, and the roles of testers in the updated test plan, it's clear that this process is iterative. It's about constant refinement, communication, and ensuring everyone has the resources and clarity they need to deliver the product successfully. Now imagine we are working on a project. We are starting to build the user interface of the application. Let's take user story one, which is the sign up page. Okay. Um, Wait, let me show you something. Now here you can see for user story one, there is the sign up page. Sign up page. If you look closely at the user story, it says something like this. Story 1, sign up fields and buttons. The fields and buttons should be working right. The internal code is written locally by the developer's PC. This isn't multiple sprint. We are still working within one sprint. Okay, so it's still sprint one. But we are breaking down into multiple smaller parts. The first part of the sprint is the sign up fields and buttons. Okay, so the second part is the side panels. It's the side panels. And the third one is the top menu. In the side panels, we can add login, registration, forgotten my account, etc. And in the side panel or top menu, With we have options like desktop, laptops, and notebooks. Now here's the thing. With these three tasks, sign up, side panels, and top menu, they are different user stories, but we're going to work on them in the same point, same sprint. And here's the big question. Do you think only one developer can handle all three of these stories themselves? No, they can't. It's too much for the developers. So we have to get three different developers to work on this part simultaneously. So developer one will work in here, two will work in here, and three will work in here. So while these are all different user stories, they are part of the same sprint. They will all start, suppose they will all start at the same time, January 10th, and they will finish within the same sprint period. And just to make it clear, even though they are working on different user stories, they'll all start on the same date because it's on the same sprint. That's how sprints are structured. Now let's bring the testers into the mix. Tester 1 will focus on Tester 1 will focus on the sign up button and write a test design document for it. So tester 1. Then the tester 2 will do the same for here and tester 3 will work on here. The testers are preparing the design documents just like the developers are writing their codes, but for different parts of the system. Now, this is a new concept that we're diving into, but you should already have a pretty good understanding of it based on what we have covered so far. So you have probably heard of GitHub, right? So if you take a photo on your phone, do your friends get to see it automatically? No, right? They can only see it once you it into the Facebook or other social platform. So in a way, Facebook is like a cloud. And what is the cloud exactly? It's an internet-based storage system, right? Something like Google Drive, iCloud, Dropbox. So about GitHub. GitHub is a platform where developers store and manage their code. Think of it as like a cloud-based storage system specifically for the code. It allows developers to work together on project by tracking all the changes to the code. It's like collaborative space where people can contribute, share, and update code while keeping the track of the project's history. So why do we use GitHub? So it helps us to collaborate and stay up to date on to change. If you think about it, it's like an outline workspace where you can upload your code and invite others to contribute and making the teamwork smoother. When developers write code, they write it into the personal folder of a GitHub account. This folder is called branch. So it's called branch. The branch is essentially their workspace, and no one else can directly mess with it unless they have permission. Okay, so each developer works in their own branch. Once they are done writing their code, they don't just upload it directly to their main project. They send a pull request. Okay, they send a pull request. A pull request is a request to merge their code into the existing main project. It's like saying, hey, I have finished working on my part. Can you review it and merge it to the project? So who reviews it? The technical lead or the person in charge of the overseeing the development. This person will check if the code is correct. They'll review the pull request and once they're satisfied, they'll approve it. When a developer submits their code for review, all other developers may be involved in the code review meeting. This is important because it allows the team to ensure that the code doesn't break anything and that it follows the project's guidelines. In these meetings, the technical lead will check the code and if everything looks good, they will approve the pull request. Now, do you see how the system works? Each developer is working on in their own space, like branch. So here there is branch for him, and branch from him also. For example, uh, the link might look something like this: www.github.com/SLU store. This is the point where all the code, whether it's to the top menu, the sign-up fields, or the side panels, are combined. So this is where all of them are together combined. Do you see how the system works? Each developer work their own spaces. They send a pull request to the technical lead for the review. And once it is good, the code is then merged into the project. This keeps everything organized. So first, they are assigned to one sprint into different devs. Then they have different devs have different GitHub branches. From there, they have their meeting and they integrate their project into the master branch. After that, the technical lead sends the repository link to the DevOps. The link is here. After that, all of these are combined and a web application is deployed. So let's say where we are in the agile development environment and we have started a sprint. Think of the sprint like a mini project that lasts for a set of specific time. So we are dividing the sprint one into three user stories. Story one, building the sign up form. Story two, creating the site panels with options like login and registrations. Story three, working on the top menu. Each developers are assigned to this task. In this way, they can work on parallel, and while one developer works on one page and the other can work on the second page. So the developer in GitHub, the developer gets a personal folder which is branch where they write and test their code. The branch is like a sandbox. It's like a private space where they can experiment and make changes their project. Once they are done all the changing of the project, they submit a pull request to the technical lead for the review. After the review, the technical lead, if the quality is good, he adds it to the with the rest of the project. So the technical lead looks at the code quality, the consistency, and the integration, like how much the code is clean and easy to read. Is the code in line with the team standards? Will it work well with the other features being developed by the other team? If everything checks out, all of them goes to the technical lead, master branch. The master branch is like the main version of the project, okay, where all the completed features are stored and ready to be deployed. After the code is merged into the master branch, something magical happens. A repository link is generated. This link is like a shared URL. Then it is passed along with the next team DevOps. The role of the DevOps is to automate everything. They stand for development and operation. And their job is to make sure that the software gets built, tested, and deployed smoothly without a hitch. One of the development tools is called Jenkins, which is like a super smart automation system. It helps them to build the software, test the software, and deploy the software to the product environment. The developer teams push the repository link into Jenkins. Then Jenkins runs through a build process where it compiles the code and prepares it for the deployment. Once the build is ready, Jenkins generates a development deployment link, which is like a URL. In Jenkins, there is a button called build trigger. Build trigger. When the DevOps team clicks it, the whole process kicks off building, testing, and deploying the software. It's like hitting the launch button. Once the process is complete, Jenkins will have a team ready to go. Okay, you understand this now? Now, what does the team lead do? Once the DevOps teams triggers the build and deployment, the test team gets an email notification with the deployment link. The test lead then uploads the link to the test environment, a system like Confluence. Afterward, the test lead informs the testing team that the new version of the software is ready for testing. Now the testers can access the software using the link and start testing. They'll test different features and ensure everything functions properly and report if any bugs are found. It's all about making sure the product is high quality before it goes to the end user. So to recap, the sprint division break the work into user stories, each assigned to a different developers. Then the developers work on the branches on GitHub and submit a pull request. After that, the technical leads review the code for quality and consistency and merge it to the master branch. After merging, a repository link is created, which holds the latest version of the software. Then the DevOps team use Jenkins to automate the deployment process, and Jenkins compiles the code, runs the test. The test lead receives the deployment link, uploads it to the test environment, and informs the tester to start the testing. So, with all the tools and the process working together, the whole process becomes much more efficient. Developers focus on their individual tasks. The technical lead ensures the quality of the code. The DevOps automates the deployment, and the test lead makes sure everything works as expected. It's a well-oiled machine that helps deliver high-quality software faster. So that's all for today. I hope you have understood everything properly. If you have any question, you can ask me. So I'll see you in the next class. Till then, take care.